Okay, welcome to Phil 12 in this strange quarter of fall 2022. So the first 2 weeks have been moved online. So I'll be recording these lectures and posting them to the Media Gallery and Canvas. They're also available on my YouTube channel if you have any Canvas problems. Um, I'll send you guys a link to that. Um, so ultimately, the plan is to be in person as soon as we're allowed to, but I am going to make this whole course possible to take remotely if you need to, because I know lots of people may need to. So I'll also be having those lectures recorded, and those will be posted to the Canvas. So I'm currently recording this in my home. I just got over a cold. I'm sucking on a cough drop, so if I start coughing and stuff, apologies. I'll try to keep this to the 50 minutes, hopefully less of a normal lecture. So in this lecture, I'm just going to sort of introduce you to the sorts of things we'll be covering in this course, and then I'll go through the syllabus and try to explain everything. And then if you have further questions, you can contact your TAs or myself by email. You will be having, so for this first 2 weeks, there are not going to be like live Zoom lectures. I'm just going to be posting these recorded lectures. Your discussion sections will be live. I'll explain more as we go. So the text for the book is Understanding Scientific Reasoning, 5th edition, by Gear, Bickel, and Maudlin. You definitely need this book. I think you can rent, an online version or whatever, but you're gonna part of your grade is completing some of the exercises from the book. The whole course is designed around this book. Um, Originally, it was Bill Bechtel often taught this course, and I TA'd for him, and I really liked the way he ran it. But his course was sort of based on an online text that was largely Flash based, which is now kaput. So the text sort of basically is broken. So kind of had to scramble a bit and start from scratch. And I think this text is good. I like the way it does things. Um, all going to be sort of focused around this text. Really have time to build a brand new text from scratch. These are your TAs, Samantha and Ayub. And again, they will be leading your discussions on Zoom. They'll be grading your exams and your papers. They are like your first point of contact for most things. Um, they are PhD candidates in our philosophy department here. They're both excellent. You may or may not know the philosophy department here is a very good one. It's very difficult to get in. They get hundreds of applications, and these two got in. So they know quite a bit, and you're lucky to have them. And what else was I going to say about? Uh, yeah, the discussion sections will be on Zoom, and it escapes me. It'll come back to me, right? Okay. So, what is this course about? What are we doing here? So, it's called scientific reasoning. Why is that something you might want to study, right? Particularly, maybe you're not a science major. You may be taking this course because it satisfies sort of quantitative requirement, but maybe you're a humanities major or an art major, and um, you don't necessarily feel like you need to be understand quite how scientists think. Well, it's not quite a course on how scientists think. It's a course on how we understand all of the scientific information that really, in this day and age, you can't get away from and affects your life in deep ways. I mean, once upon a time, if you lived in the 1200s, like this fellow in the photo here, yeah, technology probably would not change over your lifetime or even over several generations, right? You would still be pulling the same sort of plow with oxen, using the same techniques. Um, these days are vastly different, right? Right now, you're constantly deluged by new developments in science and technology. And in order to navigate the world we live in, you do have to know a bit about science and what counts as good science and bad science and how to live your life and process all this information. I mean, we're all sort of up to our necks in it right now, right, with the COVID pandemic. Um, all of a sudden, these microscopic life forms are posing a threat to you and your family, your loved ones. Um, you can't see the viruses, right? So there's not a lot of common sense that you have about these invisible entities, we are relying on scientists to tell us um, how these things behave and how we need to behave in order to stay safe, right? And notice that often it's being updated, right? Because it's a new virus. We don't know everything about it off the bat. Um, and then once you get all this information, there's a question of how you incorporate it into your life, right? So if once you get the data and the probabilities of like infection and different situations, then you ask yourself, okay, how do I behave in light of this information? Does this mean that I need to wear masks all the time? Do I need to sleep in a mask? Do I need to wear it outside? Or is it okay to take it off when I'm outside? If I'm vaccinated, can I hang out with my friends without masks? Um, should I just never leave the house at all if possible, right? Um, you may have noticed that lots of people have decided to pursue uh, all of these options, right? And it's not always clear that what they're doing is the most rational thing in the light of the information, because not everybody knows how to process this information and then apply it to their own lives. So we're going to give you some tools to do exactly that. It's not just during pandemics. I experienced this. I had a child a couple years ago, and if you become pregnant, right, you're all of a sudden you want to know how to, responsibly deal with it, and you're bombarded with all these claims. They often conflict about how you're supposed to behave, what's the best way to behave during pregnancy, or the best way to rear an infant. Um, they'll tell you don't drink wine. It's okay to drink wine. Don't eat sushi. It's okay to eat sushi. Um, and if you're not used to analyzing these scientific reports, it can be difficult to know which one to believe, right? Um, because think about it, right? So just this claim about, okay, if you're pregnant, is it okay to drink wine? Well, what do scientists do? How do they know, right, if it's okay or not? Do they take two different groups of mothers, right, that are pregnant, feed one tons of wine and sushi, and make sure the other one doesn't drink any wine or eat sushi? No, I mean you can't. There's so many things we'd like to know, but it would just be unethical to do those studies in the most rigorous way, right? So often, for many of these sorts of claims, particularly about child rearing, where you can't just take babies and do experiments on them, pardon me, we rely on sort of much weaker methods of trying to figure out these causal relationships, right? Um, but without exposure to the differences in these different types of studies, you might not know that what you're being told is actually maybe should be taken with a grain of salt since it hasn't been studied as rigorously as it could, right? Um, so I'll just put this on the table now. We're going to be talking about lots of different scientific episodes, right? Different sort of examples from the history of science and current science. I'm not an expert on all of this stuff. Neither are the TAs. Um, Literally no one in the world is an expert on this many stuff. You'd have to have like 50 PhDs, right? So, um, we'll be talking about astronomy, and I'll be reciting some stuff that I sort of learned from the book. I have a little outside knowledge, but yeah, if you keep asking me details about like the science, there's going to be stuff I don't know, right? Just cut us all some slack, right? Um, my specific area of study is in cognitive science, philosophy of mind, primarily the specific area of metacognition, thought about thought, and non-conceptual content, which is like the sort of mental states that like animals and young children have. Um, so in that area, I have a bit of expertise. If you want to ask me more questions about that, but yeah, when it comes to genetics and all this other stuff, there's a limit to how much I know. Why am I teaching this course? Why is the philosophy department teaching this course rather than, one of the particular sciences? Well, um, our area of expertise is in the reasoning part of scientific reasoning. We have lots of training in logic and in sort of the formal structure of different kinds of argumentation, how we draw conclusions, right, and how we use that to decide to govern our behavior. And so this is, in a sense, a course on the logic of scientific. That's what me and your TAs know about. Um, there is going to be a good chunk of this book and of the course that's on probabilistic reasoning and statistics, but don't freak out. One thing I do like about this book is it does a pretty good job of really avoiding math almost entirely, right? And just teaching you these concepts behind how we do sort of if you want to study a sample of a population and draw conclusions about the general population and so on, or determine whether there's causal relationships going on. They do it all pretty rigorously and yet pretty math free. So I think it should be accessible to everyone. And again, I'm an expert in statistics. I know a little bit, right? But some of you may be in the sciences or in various areas that you actually do know a lot about some particular area. So I'm excited to hear from you when we get to those sections. Please speak up if it's something you know about. Enrich us. I think it'll be great if we get a lot of different perspectives and a lot of different areas of expertise because it touches on a lot of different. Pardon me. Okay, so here's just some examples from the text of sort of the sorts of scientific episodes we're going to be looking at and analyzing, right, to find the logic behind conclusions. So some scientific knowledge, right, some scientific episodes are going to be primarily of intellectual interest, and then some of it is very useful to your life. The COVID stuff, super relevant to your life and what I should do today when I leave the house, right? Some other stuff, not so much, but it still tickles your curiosity bone, right? So on the sort of most probably intellectual side of the spectrum, there's a question of the nature of the universe, right? In the 1930s, scientists discovered that the universe was expanding, right? They observe a red shift, a shift in the wavelength of light as things are moving away from you. And so to this day, they've wondered, okay, will the universe continue to expand, right? At one point, there was a big bang and the universe started to expand, and it's still in the expanding phase. And the question is, will it keep spreading out, spreading out, spreading out until it's sort of like everything spreads out and sort of just dies? Or will it start to come back and contract into a big crunch? Right? These are sort of two open possibilities. Neither one is sort of a practical worry for you. You will be long dead before either of them happens, right? But you'll have been dead for billions of years. But nonetheless, these are the sorts of things we want to know, right, as scientists. So, according to some scientists, we can answer this question if we know the density of atoms in the universe at the moment, right? If there is more than one atom for every 88 gallons of space, then they predict that eventually that's enough to, at a certain point, gravity will start to pull everything back together into a big crunch, right? But if uh, atoms are less dense than that, then it will just expand forever, right? Gravity won't be able to pull everything back together. And in some way, right? If you by measuring the strength of extragalactic X-rays, you could answer this question of the density of atoms in space. Right? So this is like the sort of information you might get. This isn't right a scientific paper. This is the kind of information you might get just from reading a report in a newspaper or something like that. So this is sort of the level that we're going to approach this. You're not going to be expected to read journal articles. But what you need to do is identify certain key components, right? Hopefully should appear in these articles if they're good. So in this case, there's a theory, right? There's a prediction of that theory, and then some fact that would either contradict or support that prediction, right? So one theory is the universe will continue to expand. One theory is it would contract, and the prediction, right, is it's going to depend on the density of the atoms in space, and then there's one fact, something about the strength of the X-rays that would either support, right, or contradict that claim about the density of atoms. So we're going to do a lot of this, right, in the first part of the course, different examples and finding ways to pick apart those things, the theory or the model, as we'll call it, the prediction of that model, and then what fact in the world would either contradict or support that prediction. Another example, right? So global warming and climate change. This text was written in 2006, this edition. Currently, the scientific consensus on climate change is even stronger than it was then, right? But earlier in the 1980s, people started to notice this stuff, started to think about it, right? People noticed, oh, geez, 4 of the hottest years of the 20th century have all been like in the 1980s. That seems strange, right? And many scientists began to formulate this sort of greenhouse gas theory that CO2 emissions and other emissions uh, were causing the planet to warm, right? Uh, but other scientists were not convinced, right? And they thought, no, this is just sort of a statistical, this is consistent statistically with no overall increase in global temperature. Some years will be hot, some years will be cold. Sometimes you'll even get 4 really hot years in the same decade, right? But that's just normal fluctuation. Um, so you have sort of two different claims, two different theories. One, no, the Earth is warming. The other, no, it's the temperature is stable, but these are just there are normal fluctuations, right? Um, in the second part of the course, we're going to learn how to evaluate claims like this, right? So what degree of variation can you expect in a population, right? Here, the population is the temperatures, right, of every year. Um, what can we learn about a large population by taking finite samples? What constitutes good evidence of like finding a correlation between two variables, right? Is CO2 and temperature, are those correlated, right? And if they're correlated, is there a causal relation, right? And so on. Um, Again, it's going to be largely math free, but you're going to hopefully you will need to understand these principles behind the basics of probability theory and physics. But again, we'll walk you through it. It shouldn't be too bad. All right, and the last example, cigarette smoking and heart disease, right? So we've been aware of the dangers of smoking for at least 60 years, right? There's Keith Richards smoking, just not looking cool at all. Not, yeah, not making sense why anyone would want to smoke. Okay, so in it's been fairly obvious that it's been causing, right, coronary disease, number one cause of death in men over 50. Um, cigarette smoking is now banned in nearly every public place. It's banned all over campus, even outside, right? There's all kinds of anti-smoking campaigns. Cigarettes are outrageously expensive now because of the taxes. Nonetheless, the Tobacco Institute, which is a research group funded by the tobacco industry, continues to argue that all we have here are statistical claims and no causal connection between smoking and heart disease. Not been proven. Well, what would constitute evidence for causal connection? That's going to be the third part of the course, right? Which is sort of part 2 of the text, but in our course is sort of the third chunk about how do we find out when we think there's good evidence for there being a causal relationship between two factors. In this case, smoking tobacco and heart disease. Okay, so I haven't gone onto the syllabus, but here's where we pause. So lecture attendance is required, even though you can view these remotely, right? And how I'm going to get around that is every lecture, I'm going to post a link right here. So in this case, the link is https://forums.office.com. You want to go to that link and you'll want to answer the quiz, right? And you'll answer the quiz with your PID, and then it'll be a multiple choice. And it won't be A, B, C, D, E because I don't want it to be so that just anyone can sort of fill it in. So they'll be specific. It'll be like G, G, H, I, something like that, right? You're not graded on accuracy, right? You're just graded on completing it and making sure that you put in one of the letters that actually was in the quiz, right? And then I'll know that at the very least you fast forwarded to this point, right? And like put the thing in. But um, I'm trying to give you free points. Just all you have to do is show up to lecture, watch it, and you'll get some points. And it encourages people to get. I got to move a little fast. We're already at 30 minutes here. Okay, so go to this URL. This one counts. Go to this URL and answer the quiz. You will need to be logged into your Microsoft Office account, but it is free through UCSD. I'm going to try this. If it's too clunky or people can't do it, I'll see if I can find another system. But this is nice because it spits out a nice Excel sheet for me so I can log your attendance. So we're going to start with this version. Okay. And then once we understand the scientific evidence, what do we do with it, right? And this is decision theory, right? It's given, now you have all this knowledge, all this scientific information, but the next step is like, how do I apply this to my life? And decision theory is a rigorous theory of how you do that. So we're going to cover that in the final part of this course. So let me get to the syllabus, and then I'll come back to that. So let's leave PowerPoint for a minute, or I'm not. I put it in the PowerPoint actually because it's going to be online. Let's look at the syllabus, right? So the new software. So basically, okay, the slides I skipped said like, what are we doing? We're not trying to teach you a bunch of scientific information, right? What we're trying to do is basically program you, give you new software, right? So you can process this information in a more effective way. That's what the slides I skipped were. I'll post the slides if you need to see them. It's also in the text, right? But I like to get done in the next 20 minutes here. So what is the course going to look like? It's going to consist of, you have to read, right, the assigned portions of the text. You need to attend lecture, either remotely or in person. You need to attend discussion, which will be on Zoom. There are going to be exercises from the text that are assigned that you will turn in. They'll just be graded on completion, not on accuracy. There will be 3 exams and a short essay, right? That seems like a lot, but I find that it's best. A lot of these are low stakes, right? And you're going to be getting points just for doing them, right? All the lecture and discussion attendance and the exercises, as long as you show up, right? Give it a shot, you're going to get all the points. That gives you a nice leg up, right? So that when it comes to the exams and the essays, if you miss a few points, you've still done well on the other parts. And also, just by doing those like low stakes things, it just keeps you on track, particularly if you're doing this remotely, right? It can be really easy to sort of slide off. So I'm trying to keep you engaged on top of the material by giving you easy points just for doing that basic stuff. So then when it comes time for the quiz, you'll be prepared. So that's the idea. Um, okay. So here is the syllabus, and this is also obviously posted on Canvas. I haven't filled out the office hours and Zoom links for the TAs, but they will be available. That should be on Canvas by now, I think. My office hours will be 9 a.m. I'll put in the Zoom link for now for the office hours, and then once we're back in person, it'll be my office. That's my office. So I'll be on campus at 9, and then the course will be at 10. I'll do my best to post these lectures by 10 a.m. on the day that they would normally be in person. Right? So again, I gave you a course description, I think. Learning outcomes, you should, by the end of this course, be able to demonstrate your understanding of scientific reasoning by engaging in discussions, right? Completing your homework exercises, completing written exams, composing essays. So those are going to be the outcomes. Basically, we want you to understand, we want to install this software that you can take in scientific information, evaluate it, and apply it to your life. The lectures after this first 2 weeks, right, will be in person, but they'll also be available through Canvas. So I've not done this yet, but I've signed up to have the lectures recorded, right, while I'm teaching, and then they'll be posted to Canvas. So hopefully that works. That seems to have worked in other classes I've seen. And lecture attendance is required, right? That'll be 10% of your grade. So hey, free 10%. All you have to do, show up, take these online polls, right? You can miss up to 2 without losing points, right? So you don't need to get, if you're only missing 1 class, you don't need to send me an email saying I'm sick or whatever. You get 2 freebies, right? More than 2, then you will need some kind of documented excuse. Right? So just let me know. I know things are super weird with COVID, so I'm generally fairly lenient, but you do have to let me know. If it's something like, oh man, I was really busy with classes, so I didn't make it, that having other courses doesn't count, right? But if you're sick or something. Um, the assessments, right? So again, they're largely designed. I try to pack in a lot of low stakes, easy stuff that keeps you just engaged, right? That'll be about 40% of your grade right there. And then once you've done all those, then it's going to be much easier to do the stuff that's actually graded on quality, which will be the exams and the. So here are the actual assessments and the percentages. So lecture attendance, 10%. Again, you can miss 2. Fill out the polls. You want to complete them. Since some of you may be watching these videos asynchronously, just get those polls in by Sunday at the end of the relevant week of lectures, right? 11:59 p.m. and you'll get credit. And again, you can miss up to 2. Beyond that, I need some kind of documented excuse. Discussion attendance as well, necessary. you want to attend on, they're all on Zoom right now. If there's some demand to have them live in person at some point, I'm open to that. But for now, both the TAs preferred Zoom, and for now, it has to be Zoom. So we're going to keep it that way for discussion. Again, you can miss up to 2 without, you don't need excuses or anything, but more than 2, um, use. And then the textbook exercises. So they'll be on, if you look at the dates on the syllabus, it'll give you which exercises you need to complete by which date. You just fill them out, on your own in whatever Word or whatever, but then convert it to a PDF, upload it to Canvas, right? There's assignments there set up already for the various exercises. It's usually like 2 or 3, I think at the most 5, for a given section of text. And again, they're going to be graded on completion, right? You're not going to get like extensive notes on those, right? They're just going to check that you've done them and that you've made a reasonable attempt. And then in section, you can discuss like how you did, whether you did it correctly or not. But again, that's another easy 20% of your grade if you just give it a good try, right? Then you're going to have 2 exams in class, right? 50-minute exams. There will be a remote option as well for exams, which I will explain a bit. But those will be like some multiple choice, some short answer, right? They shouldn't take too long. And there's going to be an essay, also relatively short, 15% of your grade. So you'll have like 2 prompts you can choose from. One will be about statistical reasoning, one will be about causal reasoning. It's not going to be like you're arguing for original thesis or anything. They're going to ask you to explain some of the content from the text, possibly with a specific example, like applying your knowledge of the text to that example. But it's not like a normal essay, philosophy essay or anything, right? It's just like written essay showing that you understand the material. And then you'll have a final, which will just be sort of a longer version of the previous exams, some multiple choice, some short answer, maybe a short essay, and it's going to cover the whole course, right? And again, all of that can be taken remotely if necessary.